Good morning, everyone. I'm Laurent Bonniere. I'm working for Air Efficience, which is a French engineering office specialized in ventilation. I'm going to present you Ductwork airtightness in French regulation and FDE 51767, which is a test procedure and measurement method for mandatory tests on site. This presentation is divided in three parts. First part will be about Ductwork airtightness in French regulation, and more exactly in energy performance regulation. Second part, I will present you an example of EP calculation, and the last part will be about FDE 51767. So in new building in France, the Ductwork class is an input data in the energy performance calculation. In France, the EPA regulation is RT 2012, réglementation thermique 2012. For this regulation, there is no minimum requirement for Ductwork class. You can use default values for airtightness, Ductwork airtightness, and this default value is equal to 2.5 times class A. So if you use this default value, there is no mandatory test. In the energy performance calculation, the leakage has an impact on heating loads, and if there is a cooling system, there is also an impact on the cooling loads. If a better value is better value than the default value is used in the EP calculation, there is a measurement. A measurement is required to justify this better value, class A, class B, or class C, and this measurement has to be performed by a qualified independent technician. Since 2013, in France, there is a label, F Energy Plus label, and since 2013, F Energy Plus label requires a class A. On this figure, this figure shows the evolution of the number of measurement. As you can see, since 2013, the number of measurement has increased. Just for 2017, at this stage, it seems that not all measurements are included in the database. One more precision on this figure. You can have the use of the building. In green, there is no non-residential buildings. The number of measurement for non-residential buildings. In orange, the number of measurement for multi-family building. In blue, the measurement for single-family house. Now, an example of EP calculation, calculation for a single-family house in the north of France. There's nothing specific. It's a usual family house, and in the EP calculation, the designer have to precise the characteristics of building envelope, ground floor, the roof, the external wall, and the characteristic of the windows. Also, he has to precise the technical characteristic of technical equipment, heating system, hot water lighting system, and of course ventilation system. And for the ventilation system, the designer has to uh, precise the ductwork airtightness class. He can select default value, class A, class B, or class C. Here is in example, it's mechanical ventilation with heat recovery, nominal airflow 105 cubic meter per hour, with an exchanger of 82% for heat recovery efficiency, and supply ductwork and extract ductwork. There is 25% inside conditioned space and 75% outside conditioned space. If default value is used, we have heating consumption of 30.6 kilowatt. If we use class A, you can see that there is energy saving 1.3. Class B, it's higher energy saving 2.0, and class C 2.3 energy saving. So it's just an example to illustrate the airtightness class in EP calculation. That absolutely not a sensitivity study of airtightness class impact on EP calculation. Just to see that if you have default value, there's no mandatory test, but the performance will be less efficient. If you choose, if you use class A, class B, or class C, the result is more efficient than there is a mandatory test to justify class A, class B, or class C. Then the ductwork airtightness measurement has to be performed by a qualified independent technician. Today, at this stage, there are about 100 certified testers according to a national qualification scheme for ductwork tester, and this measurement has to be performed according to the FDE 51767. FDE 51767, it's a national guidance to specify how to use European test standard on site with a various kind of ductwork, different materials, different shapes, for different use of building, for non-residential building, but also residential building, multifamily building, or a single family house. To take into account the usual operating pressure of the ventilation system. In fact, the usual operating pressure is not the same if it's in a non-residential building or in a residential building. And the FDE 51767 explain how to sample and how to take into account specific devices like plenum box, flexible sleeve. This document refers to European standard for test, like EN 12237 for circular sheet metal ducts. 10507 for sheet metal air duct with rectangular section. 13503 for non-metallic duct made from insulation ductwork, and 12599 for test procedure and measurement method to hand over air conditioning and ventilation system that Frank has presented earlier. Also, this guidance refers to 14239 for measurement of ductwork surface area, only for individual system in residential buildings. It's also possible to calculate the surface area with another method. The ductwork surface area with this another method is equal to 0.1 times the floor area of the dwelling. Now about test pressure, it depends on the ductwork. If it's a supply air duct, the test pressure will be a positive pressure. If it's exhaust air duct, it will be a negative pressure, and the test pressure depends on the use of building. If it's a residential building, a single family house or individual system, the test pressure will be equal to 80 Pascal. If it's a multi-family building, the test pressure will be equal to 160 Pascal, and for non-residential building, it's equal to 250 Pascal. And for non-residential building, if the design pressure, the absolute value of the design pressure is higher than 300 Pascal, a second test has to be performed at with a test pressure equal to design pressure. Now, how to sample for individual system. 100% of the ductwork has to be tested. Exhaust ductwork and supply ductwork. Now for collective system and non-residential system, in large air duct system, the test can be performed in a part of the system. There are many requirements. The first one, all kind of ducts have to be tested. Size, all size of duct of the system, all type of duct, if they are circular and rectangular, we have all type of section, and all type of accessories of the system have to be tested. And one of those requirements shall be met. Case 1, the ratio L AG higher than 1, and the ductwork surface area tested higher than 10 square meter, and AG, the surface area higher than 10% of the wall, the surface area of the wall system. Case 2, for usually for non-residential system, at least one wall floor to the ventilation unit, and the surface area higher than 10 square meter, and surface area higher than 20% of total area of the system. And the last case, case 3, at least one wall column to the unit ventilation unit and surface area higher than 10 square meter and higher than 20% of the 20% of the total surface area of the system. Here to illustrate the case 2, here are the part of system that is tested. Here it's sealed. We are one wall floor to the unit, and the area tested higher than 10 square meter and higher than 20% of the surface of the wall system. And case 3, here the part of the ductwork tested, at least one column to the unit, and the surface area higher than 10 square meter and higher than 20% of the total surface area of the wall system. For building where if there are several ventilation units or handling units, there are also a method of sample selection for this unit. If there are less than 5 units, each ductwork has to be tested. If there are more than 5 units, the number of ductwork to be tested is equal to this formula, 5 plus 40% of the number of units minus 5. The last point, when there are specific devices, the FDE 51767 give penalties if some part of the ductwork can be tested, and these penalties are used for the EP calculation. Example, the method to seal off the diffuser for exhaust unit or supply unit, or the climate beams. On the left, the plenum box is included in the part of ductwork tested, and on the right, the plenum box is not included of the part of ductwork tested. Now another example with specific devices for flexible sleeve. Here is a ventilation unit, the fan or air handling unit. Here the flexible sleeve, and here the ductwork. On this picture, the flexible sleeve is included, and on the right, as you can see, the part of the ductwork tested is here, and the flexible sleeve is not included. So, if these components are included or not, the FDE 51767 gives penalties, correction of measured value, and for example, on the ductwork tested, there are flexible sleeve, climate beam, and plenum box. If the 3 types of components are included, there's no penalty. But if one of these components is not included, for example, on this line, the flexible sleeve is not included, but climate beam and plenum box are included. There is a correction of the measure value. The airflow is equal to 1.3 times the measured airflow, leakage airflow. And we can have just one or no component included, and then the penalties correction of measured value is equal to 1.5. That was the last point. Thank you for your attention.